Let us discuss an example for the Hess law of constant summation summation of summation of heat. So what example we'll discuss? Let us talk about graphite is a solid carbon that combined with oxygen to form oxygen gas. Completely it burn and produce carbon dioxide gas. For the formation of the carbon dioxide gas, enthalpy of the reaction will be, standard enthalpy of the reaction will be equal to minus 393 kilojoules we say. Okay. And so this reaction can be carried out. So this same reaction will be carried out when carbon solid combined with oxygen gas. The first step, it can produce carbon monoxide gas, it can produce. Then the reaction enthalpy change will be equal to how much? This is equal to minus 110.5 kilojoules. Joules, we say. Where next step, carbon monoxide is a gas that combined with oxygen gas and forms into CO2 gas in the second step. And releases enthalpy of the reaction will be how much? It is equal to minus 283. So 283.0 kilojoules per kilojoules. So we will get. Now look at this reaction. Burning completely to form carbon dioxide. So the enthalpy change is more. Where the same, this is single step. This is so written in a single step. So single step we say consider. And so that means we can write, so delta R standard enthalpy is equal to, so some of the enthalpy changes, enthalpy changes, so two steps enthalpy changes. So according to the Hess law, now let me find out. Now, if you combine these two equations and if you try for the desired equation, so and carbon solid combined with oxygen here R42, if you combine means, so it is 1O2 carbon monoxide and carbon monoxide is cancelled and O2 gives rise to, so R42 plus O2 and the single O2 we get, and the CO carbon dioxide gas we get. And if you sum up these enthalpy changes, so then delta RH is equal to standard enthalpy of the reaction is equal to minus 393 kilojoules we'll get. So that means here the Hess law is applicable to find out so total enthalpy change during this combustion of graphite with oxygen to form the carbon dioxide. So where the same reaction takes place in two steps. One is the formation of carbon monoxide. Other one is then the complete burning of the carbon monoxide to form the carbon dioxide. So where the carbon burn partially, it can produce enthalpy changes. So minus 110. So where the carbon monoxide burning completely, it releases minus 283 kilojoules. And if you try for the desired equation, net equation, if you get from the two equations, so we will get So total energy change, enthalpy change is equal to minus 393 kilojoules. So with this example, we can prove that energy's change is a constant during the chemical reaction. So uh, now let us discuss one more example. Example is that so Hess, according to Hess law, so now one more example, another example. Let us discuss. Let us let us discuss another example. Another example for complete understanding. For complete understanding of Hess law of constant heat, constant summation summation of heat. So what is the example here I would like to discuss is that one the combustion of 1 molar, the combustion the combustion of 1 mole of benzene, 1 mole of benzene. The formula is C6H6. 1 mole of benzene in excess of oxygen gas, excess of oxygen at 298 Kelvin and at 1 bar pressure, 1 bar pressure. So produces produces heat energy which is equal to 3268 kilojoules per mole. So energy is given out in this, and during this combustion process, so the products like CO2 and water are released since it is a combustion process. So the question is about calculate, and from this calculate the standard enthalpy formation, called calculate enthalpy formation of benzene. Calculate standard enthalpy formation of benzene, where standard enthalpy formation of CO2 is given minus 393 kilojoules, whereas water has given here. The standard enthalpy formation of water is given. H2O has given here minus 285 kilojoules per mole. It is given. So this is the question is given for us. Then what we have to find out here is the question we have to find out 6C solid carbon means graphite, 3H2 gas combined to form C6H6 benzene gas is formed. For this standard enthalpy formation of this is the question mark. This we need to find out. But what is given in this equation is that C6H6 plus O2 gives rise to CO2 plus H2O. Enthalpy formation is given. Standard enthalpy formation is given minus 3268 kilojoules per mole. That means the 1 mole of benzene is subjected to combustion process. 1 mole of benzene is subjected to combustion process 15 upon 2. So then carbons are 6 and hydrogens are 3 and oxygens will be how many? 6 into 2. 6 into 2 how much? Number of oxygen 12. 12 plus 3 15. So here is 15 by 2 into 2. So 15. Now equation is balanced. Standard enthalpy formation of benzene. So given in the question, this is equation. So equation is the number 1 equation. Let us assume 1 equation this is. Now since carbon dioxide is produced 6 moles and water is produced 3 moles, then as we know that C plus O2 gives rise to CO2. CO2 formation takes place. So, but here we know that the CO2 formation is for 1 mole is standard enthalpy change is equal to how much? It is minus 393 kilojoules per mole. But but here the 6 moles of carbon dioxide is produced 6 and so here is 12 by 2. So 6 into 12. Yes. Now it is multiplied with how much into 6. This is multiplied with 6. Now the second equation is hydrogen combined with oxygen to form water, H2O. So, but here how many moles is formed? 3 moles of water is formed. Then we should write 3 by 2 of oxygen consumed and 3H2 gas combined with oxygen to form. Then standard enthalpy formation for the water is given how much? It is minus 285 kilojoules per mole, which is multiplied with 3. Which is multiplied with 3. So, and now the next equation I would like to derive is that so 6 moles of carbon graphite combined with 3 moles of hydrogen gas and consuming oxygen. So how much? 15 by 2 of oxygen moles. So produces how much? 6 moles of CO2 gas is formed plus 3H2 water is gas is formed. So for this, and if you sum up this, so how much this is equal to standard enthalpy formation is equal to how much? 3218 kilojoules per mole. and make it this is second equation. Equation number 1 and equation number 2 we got. Okay, so now from this equation, this is also minus exothermic, and equation, what is the equation 1 is? Equation 1 is that 6C solid of graphite combined with 3H2 hydrogen gas plus, so 15 upon 2 of oxygen will produce 6CO2 gas plus 3H2O water is produced. So standard enthalpy formation is equal to how much? Minus 3268 kilojoules per mole. And this equation number 2, second equation, sorry, equation number 1, this is equation, this is equation number 2, and equation number 1. What equation number 1 says? C6H6 uses oxygen. How much oxygen it consumes? 15 upon 2 O2 gives rise to 6CO2 plus 3H2O. 3H2O will form enthalpy, standard enthalpy formation is equal to how much? So minus 3218 kilojoules. But we have to inverse this equation. We have to inverse this equation. So the inverse of this enthalpy change will be the, and inverse of this enthalpy change will be the, so 6CO2 plus 3H2O gives rise to C6H6 plus 15O2. Enthalpy, standard enthalpy formation is equal to plus 3218 kilojoules we will get. And from this equation, desired equation will be, from this two equations, from the two equations, what we can get now, let us see. So I have I did inverse of this equation. Now the desired equation, net equation is that, so graphite 6C solid graphite plus 3H2 gas, hydrogen gas combine. So 15O2, 15, this 15O2 is will be cancelled. Gives rise to 6O2 and 6O2 is cancelled. 3H2O, 3H2 will be cancelled. 3H2O. Then we can get C6H6 gas plus standard enthalpy formation is equal to the difference between this enthalpy change. So 3268 plus 3218, difference is 0. 50 minus 50 kilojoules per mole we get.